All right, hello class. I'm going to do a recording for our lesson 1.9 called Prime Numbers and Prime Factorizations. And this is for the co-rec portion of the elementary algebra course. And so we'll start with your workbooks. If you could go to page 23, please. And we're going to look at a couple of vocabulary words, prime numbers and composite numbers. So they have the prime number in this workbook defined as a counting number. And these are just examples of counting numbers. Counting numbers start with 1, 2, 3, and so on. So they define it as a counting number that's greater than 1, that has exactly two different factors, two different divisors, namely 1 in itself. So if I were to give you an example of a prime number, 3 would be considered a prime number because the only two natural numbers you can multiply to get 3 would be 1 times 3. So maybe I should put equals here. 3 equals 1 times 3. So this has two factors. Okay, the 1 and the 3. Okay, so that makes it a prime number. Another example of a prime number would be the number 2. 2 is equal to the counting numbers 2 times 1. 2 times 1. But that's it as far as counting numbers go. So that has exactly two factors. The number itself, 2 and 1. So that's a prime number. But a composite number is a counting number greater than 1 that has more than 2 different factors. Okay, so prime numbers have exactly 2 different factors. Composite numbers has more than 2 different factors. A composite number will include the factors 1 in itself, plus, at least another factor, another divisor, another pair of factors. So like, for example, 6 is considered composite. So composite number 6 is composite because 6 is equal to the obvious, right? The 1 times the number itself, 1 times 6. But 6 is also equal to the product of these counting numbers, 2 times 3. So that means you go beyond just the exactly 2. And that was what makes it composite. This has a total of 4, 1, 2, 3, 4. This has 4 factors. Okay. Another composite number is 24. 24 is a composite number because 24 equals 1 times 24, but 24 also equals 2 times 12. So if I look up 2 on your multiplication chart, 2 times 12 is 24. And then I think also 3, look at 3 times 8 is 24. And I think also 4 will work. If I look at 4 times 6, 4 times 6 is 24. So 24 is a good example. It has a lot of different factors. If I count them, 1, 2, 3, 4, 5, 6, 7, 8. This one has 8 factors. 8 different factors. Sometimes they repeat, right? Sometimes like they repeat like 9, right? 9 is a composite number. 9 is not only 1 times 9, but 9 is also 3 times 3, but that's composite. This one has, this is interesting. If you want to know how many factors, I think you could say that it has, even though you have, I think you could say that it has 3 different factors. That'd be interesting, right? Do you say you have 3 factors or 4 factors? You have 1, 2, 3, 4, but 2 of them repeat. That'd be interesting. I don't think they would ask you how many factors it has. If they did, let's see, if they did, I would probably say that you could say I have 3 different factors. 1, 2, 3, they're all different. It has 3, and use the word different factors, and I think you'd be okay with that. Okay. And if you say 4 factors, you say, well, because one of them repeats. Right? But I don't think we get bogged down with that kind of detail. But the main thing is, like, is it prime or composite? Real numbers are either prime or composite, but they can't be both. Okay. The main thing. Okay. So now let's see. It says determine the first 5 multiples for the following number 61. Show your work for full credit and separate multiples using a comma. So separate using a comma, multiples of 61. Okay. Well, it goes off the small chart, multiplication chart, and also goes off the large one, because the large one is also goes as high as 30. So yeah, you don't have a row of multiples for 61, but they want you to show your work anyway. So you just make your own multiplication chart. I would just start with 61 times 1. 61 times 1 is 61. And then just put a comma, separate that. 61 times 2, 1 times 2 is 2, 6 times 2 is 12. That's 122. So I guess the purpose of this exercise is also to make sure the student knows how to do regular, like, longhand multiplication. Okay. 61 times 3, 1 times 3 is 3, 6 times 3 is 18, so it's like 183. 61 times 4, 1 times 4 is 4, 6 times 4 is 24, it's 244. And then 61 times 5, 1 times 5 is 5, 5 times 6 is 30, so that looks like 305. You have 61, 122, 183, 244, and 305. And those are, and just double check, like 1, 2, 3, 4, 5. Sometimes students put not enough or too many. Just they want 5 multiples. So just make sure you're listing the first 5. Okay. Number 2 and number 3 are a little bit abstract. You've probably not had the opportunity to show this kind of work before in high school. So it's probably gonna be something new for you, but they just want you to show your work by doing long division. See, dividing by prime numbers. Okay. So you do have in your co-rec workbook, you do have a sheet that's got the list of prime numbers that you are going to want to have out for this section, this lesson. And your co-rec, this is Roman numeral. It looks like 5, 6, 7, 8. That looks like a 5 and then these 3 ones. So it's like Roman numeral 8. And it's got a table of prime numbers that are less than 1,000. So there's quite a few. You probably will mostly, when you try to reduce numbers, you try to see what's the greatest common divisor, right? Greatest common factor, like what would reduce the top and the bottom, and when you're reducing fractions. So you probably only just really exhaust the first 2 rows. And then also, though, there are more prime numbers than this. There are more prime numbers beyond 997. They just listed the first less than 1,000. That's quite a few. And so the number is on this sheet, that means it's prime. So you already know what prime means. Like we talked about, 3 was prime. 3 is 1 times 3. Well, you see 3 is on the sheet. And 2 is prime. See, 2 times 1 is 2. 2 is prime. It's on this sheet. In fact, 2 is the smallest prime in the world. 2 is the smallest prime. And we're not able to identify the largest prime because there's many, many prime numbers that go beyond this. And some people are really eccentric. There are some people, very eccentric people, that that's their life. They study prime numbers. That's their life. They study and write about prime numbers and make conjectures and things like that just on prime numbers. So there are some eccentric people that do that for a living. Okay. Okay. So it says determine whether the following number is prime or composite by dividing by prime numbers. Okay. If the number is composite, then you want to find at least two pairs of factors whose product is the number. So see, yeah, prime number, composite, not prime or composite number. The only way that C could work, the only way this could be not prime or not composite if it had an I, if it were imaginary, like 2I or 8 plus 5I, the real plus imaginary part. So the only way this could happen, not a prime number, would be if you had an imaginary number, like A plus BI format, like example 2 plus 3I, or for example, 6I. You know, those are not prime nor composite. Only real numbers are prime and composite. Okay, so you shouldn't have to choose C. Then you should always be giving a real number. Like 26 is real, 61 right here is real. Okay, so then it's like, okay, is it prime or composite? Okay, so right away you can use this as a tool to help you. You look to see if 26 is on this sheet. It's not on the sheet. It jumps from 23 to 29. There's no 26 on here. So these are the prime numbers. So you know it's not prime. You know it's not prime. It's got to be composite. Okay. But they want you to fill in the blanks here with a couple of factors. And they also want you to show some work. They want you to divide by prime numbers. So to get the full credit, you have to do what they're asking you to do. So I would use for 26, I would do the obvious because 26 is 1 times 26, right? So I would definitely use that because you know any number times itself is 1 times 26, a number times itself gives you back that number, right? So you know 26 is 1 times itself from this vocabulary up here, right? That's always going to be a choice, a possibility, some results. But now to get the other one, because they want you to find another pair, at least another pair. So they tell you to divide by prime numbers. So the smallest prime in the world is 2. I would try to start with, I would just start with 2 and see if you can do long division and divide evenly by 2. And if not, then you would just try 3. And if that doesn't go into evenly, then I would try 4. So you want to have a remainder of 0 is what you're interested in to show this composite portion here. So if I divide by 2, 2 goes into 2 one time. 2 times 1 is 2. 2 minus 2 is 0. Bring down the 6. 2 goes into 6 3 times. 2 times 3 is 6. 6 minus 6 is 0, remainder. So 0R, remainder. Okay, so this is good. If you have a remainder of 0, that's good. 2 goes into 26 evenly 13 times. That means that 26 is going to equal 2 times 13. 2 times 13 because the remainder is 0. So that's another factor you can put here. They want you to list at least if it's composite, then you should have, remember the definition? If it's composite, it should have more than 2 factors, more than 2 factors. So more than just 1 times 26. And we found something. We found 2 times 13 happened to work. If 2 didn't work, if you tried 2 and if you got a remainder of 1 or 2 a remainder, then you just go to the next prime number because it says divide by prime. Then you would try to divide by 3 or try to divide by 5. So you would keep trying until you find one with a remainder that has 0. Okay. Now, on number 3, it says, determine whether the following number is prime or composite by dividing also by prime numbers. But then this also says a little more. It says, if the number is prime, then they want you to continue dividing the number by prime numbers until the quotient is smaller than the prime divisor. So the quotient in your division, this is your quotient, the number that's up here. They want you to keep dividing until this number here, the quotient, is smaller than this number here. What goes here is your divisor, and it's going to be a prime divisor, because they want you to divide, it says divide by prime numbers. So okay, so when you look at your number 61, and you look at the sheet just to check it out, you see right away that 61 is on the sheet. You know that 61 is a prime number, so you know for sure you're going to circle that. Okay, but that's half the credit, right? Is identifying the correct answer. To get the full credit, you have to show your work, and the work they want to see you doing is you dividing by primes. Okay, so if I start with the smallest prime, if I start with 2, so I'm going to take 61 and divide it by 2. 2 goes into 6 3 times. 2 times 3 is 6. 6 minus 6 is 0. Bring down the 1. 2 doesn't go into 1, so it's 0. 2 times 0 is 0. 1 minus 0 is 1. That's your R. So that's not good. You have a remainder of 1. Yeah, and that's kind of why we're leaning towards prime, because you're interested, remember, in the remainder of 0. The remainder of 0 is good. It gives you composite. But when something's prime, you're going to end up getting remainders. So they want you to continue. You don't stop. That's not enough to stop there. They say if you think it's prime, they want to see you dividing until the quotient. Remember, this number has to be smaller than the prime divisor. This number has to be smaller than that. Okay, and it's not. So you keep going. So now you go 61 divided by, and then the next prime number is 3. 3 goes into 6 2 times. 3 times 2 is 6. 6 minus 6 is 0. Bring down the 1. This 3 going to 1. 3 times 0 is 0. 1 minus 0 is 1. Okay, so you see how you get a remainder again? That's not good, right? That's why we're leaning towards prime. But to show their work, they want you to continue dividing until this quotient is smaller than the divisor. So we're going to keep going, dividing by prime numbers. So now 61 divided by, and I already tried 3. So now next is 5. And I guess I shouldn't space it out so much. I should do it here. 61 divided by 5. So 5 goes into 6 1 time. 5 times 1 is 5. 6 minus 5 is 1. Bring down the 1. 5 goes into 11 2 times. 5 times 2 is 10. And 11 minus 10 is 1 arm. So that's still not good. Okay. So we got to keep going. That's why we think this is prime, but you want to keep going until this quotient is smaller than that. So the good thing is it's getting the quotient, see, is decreasing. That's a good thing, but you want to keep going till the quotient is smaller than the prime divisor. So let's keep going. And now, and you can only use prime numbers. So after 5 is 7. You only want to use prime numbers. So these are prime numbers. You're using prime numbers, okay? I'm not using like 4. I didn't jump from 3 and then I didn't use 4. I'm not using 4. Why? Because 4 is not on here. 4 is not a prime number. It's not prime, so I can't use that. I have to only divide by primes. Let me try 7. Okay, now with 7, let's see, 7 times what is close to 61? Yeah, it looks like 8, right? 7 times 8 is 56. Because 7 times 9 is too big. It's 63. You don't want to go over. So 7 times 8 is 56. 57, 58, 59, 60, 61. So if I just use my fingers, it looks like I have a remainder of 5. Okay, this becomes an 11, this decreases to a 5. Okay, now, so can we stop there? Let's see. They want this quotient to be smaller than that. Okay, we're real close. I think we just need to do one more long division. And the next prime number after 7 is 11. 11. And let's see, 11 times what? 11 times 5 is 55. Because 11 times 6 would be 66. And that'd be too big. You don't want to go over 16. So 11 times 5 is 55. 56, 57, 58, 59, 60, 61. So it looks like the remainder is 6. That's your R. Okay. So 55, 56, 57, 58, 59, 60, 61. Okay. So now look at this quotient. It's smaller than that. This quotient 5 is smaller than that. So now you can stop dividing. Why? Because the quotient is smaller than the prime divisor. That's why. So that means that means 61 is a prime number. They didn't put any blanks here. They could have, like they did these blanks. They could have. They didn't. I guess they should have. But they could say that this is 61 and then 1 here. 61 times 1. This 5 is the remainder from this long division problem. But they didn't have any blanks here, but you could, because 61 is, 1 times 61. And that's prime. Only 2 factors. 1 and the number itself. Okay. All right. So that's probably something new. You've never probably had to do something like that before. Okay, so that's a little bit abstract. Okay. And when we do take our quiz number 2, which covers through 1.9, you will have one problem, like where they're asking you to list so many multiples of a certain number. You won't have both of these, but you definitely will have one of them. You're just not sure which one. The computer randomly generates a problem. So you just don't know when it generates. Are you going to generate this type where you're getting something composite? And you still have to divide by prime numbers. It's real short and sweet, until you get a remainder of 0. Okay. Or you're going to randomly get this one, where you have to keep dividing where it's prime, and to show that you got to keep dividing until the quotient is smaller than the prime. And again, these are only dividing by prime numbers. You got to keep alert. You're only supposed to demonstrate, even over here, you only demonstrate dividing by prime numbers. Just that here you get a remainder of 0 when it's composite. Here you don't get remainders of 0. See, none of these have remainders of 0. None of these. See? And that makes it prime. Okay. Okay, now next. For the following 2 numbers, find the 2 factors of the first number such that their product is the first number and their sum is a second number. Okay, so you want 2 numbers that multiply to give you 35. But then, so you multiply here. But then when you add them up, you get the sum of 12. Okay. So I would start with the factors of 35. If I make a list, like a multiplication chart, I start with 35. So 35 is the obvious, right? 1 times 35 is 35. But when I take the sum, I take these 2 factors. These are called factors. And I try to add them. 1 plus 35 See, that gives me 36. You see, I need 12. I need 12. So that's not going to work. So then if I go in order in my multiplication chart, now I try 2. So this though, this multiplication chart, I can't really use that because it only goes up to 30. See, and I have 35. So I kind of have to make my own multiplication chart. So if I try 2, I don't get very far with 2 because 2 doesn't go into 35 evenly. See, 35 divided by 2 gives me a decimal. 35 divided by 2 gives me a decimal. So I can't use 2. And I think 3 doesn't work either. If I try 3, 35 divided by 3, see, that also gives me a decimal. 35 divided by 3. So I can't use that either. So that doesn't work. Okay, if I try 4, 35 divided by 4. Nope, that gives me a decimal also. 35 divided by 4. That's not good. That gives me a decimal. Okay, so that doesn't work. Okay, how about 5? You know, your divisibility rules, if a number ends in 5, 5 should work. Yeah, 35 divided by 5. See, that's not a decimal, it gives me 7. That means 5 times 7 is 35. Okay, so now let's test this. It has to work on both sides though. So now you come over here and you're gonna add 5 plus 7. 5 and 5 is 10, plus 2 is 12. So you see, I'm gonna put a check mark on those. That does work, see? And so your answers, the 2 factors are the 5 and the 7. The 5 and the 7. So you just separate them with commas, okay? So a lot of times students say, well, what's the minimum work you need, the minimum work? Because on the computer, you're going to type these in the computer, right? But on your paper, when you submit your work, the teacher needs to see work. So I would say minimum work needed would be tell me this and tell me this, right? Because they want the 2 numbers whose factors, when you multiply them, you get, in this case, 35. And then when you add them, you add those same numbers, 5 and 7, you get 12. Okay? So I would say minimum is, you know, what I have there in pink. And of course, this goes into the computer. So if we look at 5, it says, for the following 2 numbers, find the 2 factors of the first numbers such that their product is the first number and their sum is the second number. So you want to find 2 numbers that when you multiply, you get 24, but when you add them, you get 14. So you want to fill that in here, 25 or 24, and then 14. Okay. So if I start with the obvious, 124 is equal to 1 times 24. And I try to add them. 1 plus 24. It's too much. It gives me 25. If I try 2 times 12, right? 2 times 12 is 24. Okay, how about when I added 2 plus 12? That's good. That gives me 14. Yeah, that's good. So this works. Circle that. And this works. So I'm gonna circle that. Okay. So then your answer on your blank here will be 2, 12. Okay. 2 numbers that when you multiply those 2 factors, you get 24. When you take those same 2 factors and add them, you get 14. Okay. So minimum, I need to see that. Like, what's the minimum work you need to see? You need to reveal this, that you know you're supposed to be multiplying on one side and adding on the other side. Okay, and then 6 says, for the following 2 numbers, find 2 pairs, two factors, find 2 factors of the first number such that their product is the first number and their sum is the second number. Okay, so that's more what we've been doing. And factors of 70 and then sum of 17. Okay. So if I start with the obvious 1 times 70, 1 plus 70 is 71. So that's too much. Okay. If I try 2, like 2 times what is 70? So I use my calculator and help 70 divided by 2. Let's see if I get a decimal or not. Dividing that in half. Yeah, it gives me 35. So this means 2 times 35 is 70. So if I try to add that, 2 plus 35, nope, that gives me 37. So now I'm going to try 3. 35 divided by 3. Oh no, I get, see that decimal, that's not good. So 70 divided by 3 gives me 11.6 repeating. Yeah, so 2 doesn't work, or 2 doesn't, I'm sorry. Let me go back and put that in. Let me go back in. Put that, I shouldn't have drawn a line through that. I should draw a line through this one when you have a decimal. Okay, 3 times what is a decimal? So draw a line through that. Okay, how about 4 next? How about 70 divided by 4, which is a decimal? Gives me, what is that, 17.5? Just put a line through that. Okay, how about 70 divided by 5? Okay, so that's 14. So that means 5 times 14, right, is 70. 5 times 14 is 70. Okay, now how about when I add them up? 5 plus 14, I believe that's 19. So see, we're getting closer, see? We're getting closer to 17. Okay, so now let's see what's next. 6, 70 divided by 6. Do you get a decimal or not? 70 divided by 6. Yep, you get a decimal. 11.6 repeating. Okay, so I can't use that. Okay, how about 7 times something? 70 divided by 7. Looks like that's 10. So it looks like 7 times 10 is 70. Okay, so I take those two numbers and add them. 7 plus 10. See, that gives you 17. See that? Okay. So you want to just put those on your blank. 7 and 10. Yeah, so it turns out 7 times 10 gives you 70. And then the sum when you add them up, 9 and 10 gives you 17. Okay, so I hope that helps. Hope that this one helps. Okay, now last page. Prime factorization steps. Okay, so here I'm gonna call these that we're gonna make factor trees. We're going to make factor trees, or you can use division. So I have seen books, and I think Hawk Learning does this too. they do long division like this, where over here you have to, you would use prime divisors. Usually they try to use prime divisors when you do that. And then here we'll try to find prime divisors and circle the prime numbers. So it says break down the composite number. So these are all composites. 45 is composite. 90 is composite. 495 composite. It means you can break them down, right? More than more than just 1 times itself. And they don't want you to start off with 1 times itself. This is very trivial. So further break down any new resulting composites. Circle the prime numbers. Continue this process until all the factors are prime. Write answer as the product of only the prime numbers. And then check your answer. The product should equal to the original number. Okay, so we'll do all of that. And if I start breaking down 45, I wanna break down 45, and I'm going to use my divisibility rules. And what comes to mind is 5. Whenever a number ends in 5, you should be safe by breaking it down with 5. So it's 5 times something. Well, what? Like, well, 45 divided by 5, I believe, is 9. Yeah, so 5 times what? 5 times what is 45? So 5 times, see, 9. 5 times 9 is 45. 5 times 9. So that means that you can put here 5 times 9 is 45. And you want to circle the prime numbers. And 45 is a prime number. If you look at your divisibility, I mean, you look at your prime numbers here, your list of prime numbers, 5 is right here. 5 is a prime number. So I'm going to circle it. Told us to circle the primes. And I'm going to break down the 9. You see, 5 is prime. You saw on the list there, but 9 is not. So 9 is still, right now, the way it's sitting is still composite. So you should not use that in the answer. I'm not circling that, it's not prime, but I'm going to break it down. 9 is 3 times 3. Okay, so when you put your answers down right here, and they don't have to be in order, but you don't want to miss any. You got this 5 times this 3 times this 3. Okay, sometimes people use exponents. Sometimes people say, okay, 5 times 3 squared, because there's 2 of them. So you want to use your exponents, and if the palette key comes up, you can do that. Okay, or if you want to put in order, the 3's go first and then the 5. That would be okay. Okay, but when you check your answer, you want to multiply all of them. 5 times 3 times 3. See how that gives you 45? 3 times 3 times 5. So that gives you 45. So you don't want to go over 45. Okay, that's how you set those up. So you check your work by multiplying. Okay. And let's see. So don't see the 9 over here. Don't include the factor 9 in your answer. Don't include the 9 in here in your answer. Don't include the 9, the factor 9 in your answer. Okay, because that will make it. If you do as a check, that you won't get 45. If you try to say, oh, I'm going to use 9, you're going to say, I'm going to do 5 times 3 times 3 and then times 9. So you get 405 instead of 45. So don't overuse, don't use that. It's because the 9 got broken down into 3 times 3. That's why, and you're using that instead, because they only want the prime numbers, okay? So don't include the factor 9 in your answer because 9 is not prime. If you look at the sheet, 9 is not on. So 9 is not prime. Okay. And I circled all the prime numbers. Now, if you want to go this route, you put the prime numbers on the side. So if you want to go this route, you would say, okay, 5 times 9 is 45, right? 45 minus 45 is 0, right? And then, but then you keep going because you circle your prime numbers and 9's not prime. You can't circle it. It's composite. So then you have to further break it down. Like, what can you break down 9 prime? 3. 3 times 3 is 9. So there's your list of prime numbers. 5, 3, 3. Okay. Okay, on number 8, 90. Okay. So one way you can break down 90, there's just one way. There's a lot of ways you can break it down. Some people might say, how about 10 times 9, right? Because 10 times 9 is 90. And somebody will say, well, I'm going to use my divisibility rules. I know 2 will work. This is also divisibility rule because if it ends in 0, 10 will work if it ends in 0. But also 2 will work. If I do 90 divided by 2, that gives me 45, right? So 90 divided by 2, that gives me 45, right? Okay. And but now here, nothing's prime. 10 and 9, none of those numbers are on here. None of those are prime. But here, 2 times 45, you can circle 2 because see 2 is prime. Okay. But then these others, you've got to break them down. You got to break down 10 because those are composite. Those are composite. So 10 is 2 times 5. And then see those are prime. And 9 is 3 times 3. And you see those are prime. So that means 90 is equal to 2 times 5 times 3 times 3. Yeah, or you can put them in order if you want to put them in order. And you want to use the x, and we use x 2 times 3 times 3 times 5. Okay. Or you can use an exponent on the 3, 2 times 5 times 3 squared. All those are correct. The computer should have high tolerance and accept all those. And if you check, by multiplying here, like the bottom one, 2 times 3 times 3 times 5 gives you 90. Gives you 90. Okay. And it checks out. Okay. So this is one tree that's valid, or somebody doing 2 times 45. 45 is 5 times 9. 5 is prime, and they break down 9 is 3 times 3. But you see, all 3 students are going to still get a 2 and a 5 and a couple of 3s. So you see there, it's all valid. It's all valid. Another one, if you want to do 3, like 90. Oh, if you want to do this also like this, that by 3. So 90 divided by 3, as long as it's not decimal, is 30. Okay, and 3 is prime. And in 30, if you want to do 3 again, 30 divided by 3, because 3 is prime, is 10. And then 10 could become 2 times 5. So you see those, that's another way you can do that. And all these trees, factor trees and these stacking the prime numbers, all those work. Okay. If you wanted to do 3 times 30, 90 is 3 times 30. 3 is prime. 30 is 3 times 10. So 3 is prime. And then 10 is 2 times 5. 2 times 5. See, but you still get the 2, the couple of 3s, and the 5. So you still get the same answer. Okay, so everybody's tree can look different. There's several ways to write up your tree, and they're all correct. Okay, but you have to show your work. You just can't have the answer here and the work. And again, don't put like, see, don't put 10. Don't write 10 as part of your answer. Don't write 9 in here. Don't write 45 in here. Don't write 30 in here. Why? Because they say you want prime factorization. It's got to be prime. And 10 is not prime. 9 is not prime. Those 45, those numbers are not on here. There is no, 45 on there. See, there is no 9 on this sheet because it's not prime. Okay. And then I don't remember if I checked it. Did I check it to see if I got 90? If I check 2 times 5 times 3 times 3. So it gives me 90. Okay. Okay, let's try 495. Okay, so 495 is a pretty big composite number, but because of my divisibility rules, we should be divisibility by 5. If a number ending in 5, like this one, is divisible by 5. So 5 should work. The question is how many, right? So use your calculator. 495 divided by 5 is, wow, 99. So you can go with 5 times 99. 5 is prime. You see 5 is on this sheet. 5 is prime, but 99 is not on here, see? 99 is composite. So 99 is composite. Okay, and then when I think of 99, I think of 11. 11 times 9. 11 times 9 is 99, and 11 is prime. Okay. And I guess if you look for 11 on here, see 11, but I don't know if it goes, oh yeah, I wasn't sure. 11 and then times 9. 11 times 9 is 99. So I guess that's another way you could search for that. And then, but 9, you can't circle 9. 9 is not prime. 9 is not on this sheet. But 9 is 3 times 3. Okay. All right, so then you have 5 times 11 times 3 times 3. You have 5 times 11 times 3 times 3, which is 495. Okay. And again, if you want to use exponents, you can want to put an order. You can say 3 squared times 5 times 11. This you can use depending on your palette key. If your palette key, they let you write it with an exponent on your palette key, but if not, you just write it out like that. Okay. All right. And those are called prime factorizations. Okay. And again, if you wanted to show your work, if you like to show your work this way, I guess also another way is 15 times 33. But if you're going to do 15 times 33, this wouldn't work because you only want to put a prime number here. So if you're going to do 15 times 33, you would have to use this, I believe. 15 times 33. That is, if I do 495 divided by 15, 495 divided by 15, that gives me 33. So yeah, 15 times 33. And neither of these are prime, but 15 is 5 times 3. And 33 is 3 times 11. And then you've got, that matches these then here. Okay. Okay. And then the last problem is determine the first 5 multiples for the following number 9. Okay, so 9 times 1 is 9. 9 times 2 is 18. Usually make sure you show your work. 9 times 3 is 27. 9 times 4 is 36. So this is also to help you so you're not rusty with your multiplication charts. 9 times 5 is 45. Okay, and of course, if you needed to double check, definitely 9 times double check on the calculator. And then of course, if you want to see your multiples here, 9, see 9, 18, 27, 36, 45. 9, 18, 27, 36, 45. 1, 2, 3, 4, 5. Okay, so definitely that works. Okay, and then you're still showing your work, and then you're double checking that. Okay, that's the lesson 1.9. So I hope that was helpful. So remember, in your workbook, you do have a take-home sheet for extra practice, and then you can check your work in the back because the answers are in the back, and then of course, do the work on the computer. Remember when you're doing your work to practice showing your work. When you do your work on the computer, I'm thinking that they're doing a lot of practice, like your work is looking like this. Your spirals should be looking like this, and you should have a math spiral where you show all your work, and you should be filling it up, and it should be looking like that when you do your work, okay? Not just answers, not just poof answers, and no work to support that. So this course is supposed to train you to be showing your work, to prove your work beyond a doubt. Okay. In case you want to grow up to be lawyers, you prove beyond a shadow of a doubt. Okay, so we're setting practice up for that. Okay. All right. Hope that helps. Take care.